Hey guys, welcome back to another lesson. Today we're going to talk about the rational zero theorem, okay? And this one in particular really does encompass everything we talked about in this entire chapter of polynomials comes together. And it's really cool how it plays out. I'm going to do two parts to this video. Part one is just introducing it and trying an example out. Part two, we'll do at least two more other examples that you can watch and see. So I'll be uploading that video hopefully relatively soon. But today, let's just focus on what is the rational zero theorem, okay? So we're going to jump into it. Let me just go ahead. I'll share the PowerPoint up here, okay, just to get the basic definitions and concepts out of the way. So let's go ahead. Here is the rational zero theorem. And here's what it states. If we have a polynomial function with integral coefficients, then every rational zero of p of x equals 0, that's what it is when it is a zero of that form, is in the form of p divided by q, a rational number in its simplest form, where p is a factor of the constant term and q is the factor of the leading coefficient. Okay? Now, the best thing to do is just look at an example to understand what that means. Okay? So let's go ahead and do that. So remember, we're trying to list all the possible zeros. Zeros, another word for solutions. Okay? I know it's hard at times because we use the word zero so many different times in this lesson and other lessons. This zeros is another word for solutions here. Okay? So I have two examples that we're going to do this to. First, we're going to locate what the p-value is of this polynomial, according to the theorem. The p-value is always the constant term, so that's going to be a 4 for that guy. Okay? All right. Next, q is going to be 3. It's always the leading coefficient of the leading term. If this gets scrambled, don't always assume it's the first term that's listed here. Okay? You have to look for it if it's not written in a proper format. Okay? Now, what I'm going to do is I'm going to list factors of 4. And I have to include the negative values with those factors too. So you're going to see me write plus or minus for each one of these. So factors would be plus or minus 1, plus or minus 2, and plus or minus 4. Those are all factors of 4. Be careful, I'm not talking about multiples. So I'm not talking about 8, 16, 24. Okay, those are multiples of 4. All right. Factors of q, so that's 3. So the positive, negative 1, positive, negative 3. Okay? Now, to figure out what are my possible zeros, my possible solutions to this guy, I'm going to take every combination of p and divide it by q. And whatever the outcome is, those are all my possible zeros. So what I do is I just pick one to start with. Okay? 1 over 1. And when I simplify, it's still plus or minus 1. Okay? And I'm including the negative in there. Okay? So I'm not just doing 1 divided by 1, 1. So I'm not listing it this way. Okay? If I write it expanded, well, I'm not going to have enough space to do that for every single problem, right? So the plus or minus is condensing it a little bit. Okay? Then we have 1 over 3, so plus or minus a third. 2 over 1, plus or minus 2. 2 over 3, plus or minus 2/3. Okay, so far so good. And then 4 over 1, plus or minus 4. And 4 over 3, plus or minus 4/3. So, what did we just find? Well, let me tell you. I already said it, but now since we actually have them, this is all possible, keyword possible, real zeros of the polynomial. Okay? What I could do is I could plug in 1 into here and see if I get 0. I could plug negative 1 in here. I could do the same thing with a third, 2, 2/3, 4, and 4/3. I could do the same thing. Now, I know this isn't written in numerical order. This is just written as to how did I figure this out so I didn't miss a fraction. Okay? All right. Let's try this guy down here. Okay? Let me just adjust this. So the p-value is the constant. That's right here. It's -15. And the the Q value is what's in front of here. That's a 1. Okay. So now factors of p. So we're looking for factors of -15. So it'll be positive -1, positive -3, 5, and 15. Those are all factors of it. Factors of Q, hey, that's going to be real easy. This is what? Positive -1. Now we write them as a fraction, every combination that we can come up with. Now here's the good news. If this is 1, every one of these I can write over 1. So really, this is just the factors of P. So that's just this guy. Okay, so that's it. That little section, okay? These are possible solutions to this quartic function, okay? And just to clarify here, just the factors of P since Q is 1, okay? Now, this specific case is the corollary to the rational zero theorem, okay? So if you look back on my PowerPoint slide that I just clicked away from, all right, you'll see corollaries at the very bottom, something that we tack on to a theorem, okay? Corollary theorem states that if this is just 1, then your possible zeros are just the p-values, okay, for this specific reason. That's why I didn't explain it at first, because it wouldn't make sense without an example, okay? All right, pretty cool, huh? Now, let's put all of this together, all right? I think that's what we need to do next. So, here we go. Let me just change this. Okay. So this is a rectangular solid. I'll put that over here. Rectangular solid. Okay. And what we're going to do is figure out what dimensions satisfy this guy. The volume is 1,120 cubic feet. Okay. This is 4 more than the width. This is 2 less than the width, or the height, whichever way I'm looking at it from here. So what would X be to satisfy that volume? Okay, and you're probably thinking, there's no polynomial here. Why would I have to find a 0? Well, there will be a polynomial once we plug it into the formula here. Volume is equal to length, width, and height for any sort of rectangular or just cube solid there. So let's go ahead and plug the values in. Just like that. We're going to continue to solve here. I'm going to multiply those two together. I get x squared plus 4x. And x minus 2 just comes down. Then I'm going to multiply these guys into this. So x cubed minus 2x squared plus 4x squared minus 8x. Okay. And if I'm going too fast, just you can pause the video. I'm trying to make this maybe not as long of a video. Now I'm going to bring this over here, and I'm going to combine the x squareds together, all in one step. Okay. So 0 equals x cubed plus 2x squared minus an 8x minus 1,120. Okay. This guy right here, whatever answers satisfy this, give me the dimensions of this guy. Okay. And we're going to use the rational zero theorem to do that. Just to list the possible zeros, because then we can use that to figure out the other guys. So here's what we're going to do. Okay. The p-value for this guy would be negative 1,120. The q value is going to be a 1. And already you're probably groaning about this. You're like, oh no. There's a lot of factors for that, isn't there? There are. Now, because q is 1, do we have to worry about anything else? No. We can use the corollary. So p over q is just the factors of this guy, right? All right. I'm going to list them. I'm not going to list all of them. There's a reason why I'm not listing all of them. I stopped there. All right. And over here, I'm sorry. There we go. It's hard to see. All those dots mean there's more factors. I just stopped. There's a lot. All of these could make this guy a 0. Ouch. Okay. Let's try and cut out some answers that we know won't work. Now, look at what I'm doing. I'm finding dimensions here. So do I really need the negative values? No. So I'm going to put that down. Since we need the dimensions of the solid, we won't include negatives, okay? We're not going to include negatives in there. Okay, less to sort through, still a little bit of a pain. Okay, so what else could we do to figure out? Because here's the thing, could we have more than one of these positive guys make this work? We can. Since this is a third degree, we could have 3 possible, well, we will have 3 answers. We don't know if they're real or imaginary, but we don't want imaginary in this problem. So what could we do? I'm glad you asked that. So here's what I'm proposing, okay? Let's use Descartes' rule of signs to find the number of zeros we could have. And number of, I'm sorry, I should put this here, real zeros that we could have, okay? We did that in the previous lesson. That could really help us out here. So you ready to give it a shot? So going back up to here, I have no sign change. I have a sign change, y means yes. And I have no sign change here. So because there's one sign change, I have one real, darn, I can't write. One positive real 0. Okay. Perfect. All right, that's good news. So we don't need the negatives. We know that one of these positive answers will make this work based on the rule of signs. Okay, good. See why we learned that in the previous lesson? That helps us out a little bit, huh? Okay, so we're getting closer. I can't solve this polynomial the way it is. I can't factor by grouping. It's not going to work. So now it comes down to I have to plug these into here and see which one works. Okay. Now, instead of plugging them into here, we could use synthetic substitution. Okay, and that's what we're going to do. Actually, I think that would be a little bit easier, and it'll also help us with some other things, which you'll see soon. Okay. So I'm running out of board space. Just tilt this up a little bit. I'm going to push you back a little bit. There we go. So let's go ahead. There we go. Okay. All right, so we know 1 works. I mean, we don't know if 1 works, but we know that there's going to be at least 1 0 here that we're going to be looking at. So we're going to use synthetic substitution to find the 0. Okay? Now, here's what I recommend. You have technology. You have a graphing calculator. What you could do is plug this into here, okay? And then look down your list and see which one of these gives you a 0. Very efficient, and I'm encouraging you to do that, okay? But if you didn't have this, you could use synthetic substitution to figure out if it works, okay? So here's what I'm gonna do. I'm gonna give you one case where it didn't work. I'm gonna give you the correct answer that it does work. Does that make sense? Okay. So let's go ahead and do this. So we're going to try 1, just to see if 1 works. Let's go ahead. We'll set up our synthetic division problem. 1, 2, -8, and -1,120. Now, why am I using synthetic substitution? It could be a little bit quicker. It honestly could. But the other thing is, if I'm using synthetic substitution, I want to make sure that the remainder becomes 0, because that tells me that it has to be a solution when the remainder is 0. Okay, that's using a concept from a previous lesson. All right, so here we go. So that's a 1. There's 3. 3, -5, -5, -1,125. So nope. 1 is not a solution. Okay. Now, because I use the graphing calculator, I use the table function to figure this out. Okay. 10 will work. Okay. So let's just plug 10 in to confirm it. Okay. So bring this down. Okay. And once again, multiply, we get 10. Then we get 12. Multiply, get 120. Get -112. Oh, sorry, positive 112. Multiply, get 1,120. And I get a 0. So yes, 10 is a 0. Okay. Now, that's great news. Because isn't that what we discovered? There's only one positive real 0. Do I have to go further and check other solutions? No, I'm done. Okay. That's why I did rule of signs, because it was important for us to figure out if there are more than one answer. Okay, because if it is, then we have to keep going, huh? Here's a side note. What does this give me here? I get x squared plus 12 plus 112. Sorry, there's an x there. Okay. And I'll zoom in on this part a little bit so you can see better. Okay. Now, you're probably thinking, if this was factorable, I could figure out what other zeros they have. But we already know there isn't. But let's say you didn't use rule of signs. What else could you use? Well, it is a quadratic. Okay. You could use the discriminant to figure out if there are any more positive zeros out there. So remember, the discriminant is b squared minus 4ac, right? So let's take a look at that. We have 144, that would be b squared. Okay, minus 4 times my a times my c value. Now, 4 times 112, is that bigger than this guy? Yes. So this is a negative discriminant. So that means we have what? 2 imaginary solutions. So this is just supporting the rule of signs. Okay. Now, am I requiring you to do that every problem? No. I'm just showing you that previous stuff we've done in the past can help you with this. Okay. All right. So we know 10 works. So now we have to plug it back in to this guy. There we go. So that means this is 10. And 10 minus 2 gives me 8. And here we get 14. Okay. Those would be my dimensions for my solid. Pretty cool, huh? How we deciphered this. Because here's the deal, guys. If this becomes not solvable with what we have currently in our tool belt, then we have to come up with something different. And this rational zero theorem is doing that. Okay. And like I said, we can use synthetic substitution to figure it out. Here's the good news. This is even better. And we'll see this in part 2 of the video. If one of these zeros works, then guess what? I can continue factoring this by using the other zeros. I can keep going with it until eventually I get all possible solutions, which is the topic for part 2. Okay. The topic for part 1 is, what are they and how can we use them to find just something very basic for right now. Okay. A lot of work, I know, but hang in there. You'll be okay. Honestly, you'll be okay. So if you have questions, please let me know. Like I said, look forward to part 2 where we do some other examples where we don't have constrictions like this. Because we have dimensions, we could use the negative values, but we'll talk about those later. Hope you're doing well, and I will see you in the next lesson video. Take care, guys.